Separating mixture. Already we arranged that a mixture is a physical combination of two or more substances that are not chemically combined. As an example, when we mix water and sand, the particles of sand are closely combined with the particles of water, but there are no chemical bonds joining sand particles to water particles. Accordingly, it's easy to separate each substance in a mixture alone. In this video, you are going to explore filtration. Let's start with this example from our daily life. In front of me, a mixture of water and herbs. Do you know how to separate this mixture? If your answer is by using a sieve, then you're correct. If we look at the sieve closely, we see these small empty spaces. If the size of the substance is smaller than these empty spaces, then it will pass through these spaces. Otherwise, the substance will stay on the top of the sieve. It's obvious that the size of herbs is larger than the empty spaces of the sieve, and the herbs can't pass through the sieve, but water can do this. As a result, herbs are separated from water by using a sieve. Well, am I able to separate sand from water by using a sieve? No, because the particles of the sand are very tiny and they can pass through the sieve. And then water and sand together, they will pass through a sieve. As a result, we can't separate sand and water by using a sieve. Sand is separated from water by using filtration technique. In a filtration technique, we're going to use the filter paper. The function of a filter paper is similar to that of a sieve, but the main difference is that the empty spaces are so tiny to a degree which makes them invisible ones. These tiny spaces in the filter paper, we call them pores. In front of me, a picture of a filter paper that is highly enlarged in order to make the pores visible. By looking at the sand particles and at the filter paper, it's clear that the sand particles have a larger size than the invisible pores, and then they won't be able to pass through the filter paper, so they will stay at the top. Hence, when you add sand with water to a filter paper, the sand won't be able to pass while the water will pass through the filter paper. Hence, water will be separated from the sand. The substance which stays at the top of the filter paper is called residue, which is the sand in this case. And the substance which passes through the filter paper is called the filtrate, which is water in this case. Do you know other examples of filtration from our daily life? Usually we use filtration frequently in our life, mainly to separate a solid which is not dissolved in the mixture. In front of me, a coffee filter, which is used to separate the brewed coffee from the grinded coffee beans. As coffee beans have size larger than the pores of the filter paper, they stay on the top of the filter paper and they are called residue, while the brewed coffee passes through the filter paper and then we can drink our coffee free from the granulations of the grinded coffee bean. Another example of filtration, it is used in cooling in order to protect the air conditioner from dust. Following the same concept, the particles of dust have a size larger than the pores of the filter paper, so they'll be trapped and form the residue, while clean air will pass through the filter paper. And this picture shows clearly the same concept of using the filter in order to protect the motor from dust.